Hi. So far, we have discussed the choosing the projects based on different size and different life. Now we're gonna look at a solution, a problem where you have to choose for the projects which have which where you have budget constraints. You have a limited resource, you have limited money, and then you have to choose different projects which are going to use your resources in a different manner. So we're gonna explain you this with the help of an example. So here you are evaluating the projects with different resources requirements. So in this example, we just simply basing the highest NPV may not be the right solution because the initial investment or the resource allocation may give you un optimal decisions. So in that case, normally we calculate profitability index, or we call it value created divided by the resource consumed. So all the NPV divided by the initial investment. So you will get an index, let's say normally 1.5, 1.6, 1.2, and then you will rank all the projects based on the profitability index. That profitability index will decide what should be your resource allocation, what should be given the priority to minimize the unused resources and maximize the values. So the example here is you have, let's say, three projects. Total is $200 million. Now you have three projects, $100 million. Initial investment is $200 million. And then the initial investment is 220, and project C initial investment is $80. So now you have a choice either to accept first project because the NPV is higher and get 100 millions, or in choose the project B and C where you will be still be able to use your initial uh, budget of 200 million, but will be able to get $145 million as a NPV. So how did we do that? We calculate the profitability index, which is given here, 0.5 for the project 1, NPV divided by the initial investment. So 0.5, 75 divided by 120, 0.625, then 70 divided by 80, 0.875. So we rank them in the reverse order, in the descending order. So 0.875 project C will come first, then project 6, and then the last one A. So first we will accept the project with the 80 million investment. The leftover money we will use it for project B. So that's one way. Another example of this is going to be where you have budget and money constraints. So let's say you are a large network company and you have a project of $17 million, the NPV of the project. This will require you 50 engineers. Now you have 190 engineers available, but you are unable to hire extra engineers in the short run. Therefore, the router project must complete the following four other projects with these engineers. So there are projects, router, project A, B, C, D, E, where the NPVs are given different and the engineering headcounts are given different. So in this case, again, what you will do is divide NPV with the resource allocation. So how much is the NPV per headcount? So once you do that, then you will be able to select the engineers. So NPV, engineering headcount, divide by the profitability index. So here you get and then sort them out based on the highest NPV per headcount. Now you calculate the accumulative headcount required, right? 0.48. So 47 is used. Then the second project 32 is used. Then the last project 58 is used. And then the final router project, which is going to use the 50. So out of 190 headcount that we are able to use 187 and get the maximum value. There are projects which we are selecting or rejecting. Let's say, for example, this $14 million project C, but project A and project F we are accepting, which has $12.9 million, which is seems to be absurd based on just only the NPV method. But per head count, it makes different sense. So we cannot just choose rely on only one method. We have to look at different multiple options that we have for profitability based on the profitability index. So by ranking them on profitability index, you are able to use the resources. Now there are you have profitability index again have some shortcomings. It may not give you the accurate answer if the some resources are not fully utilized, and the benefit of focusing on increasing the binding resource content